Hi everyone, I'm Jenny Pearson and I'm the Global Clinical Marketing Specialist for the LOGIQ E9. I'm here today to talk a little bit about our B-Flow technology on the system. B-Flow technology is a technology based on B-mode imaging. When using B-mode imaging, the tissue is visualized and the blood flow is not due to the weak echo signals of the red blood cells. In contrast to B-mode imaging, B-Flow suppresses the tissue and enhances those weak signal echoes. This gives us the ability to see small vessel perfusion and hemodynamics within larger vessels. A major advantage of B-Flow technology is the ability to show the true vessel diameter, which gives you the advantage of showing the delineation of the vessel wall in cases of carotid plaquing or small vessel perfusion. There is a clinical need to visualize blood flow and vessel wall structures in the diagnosis of various vascular diseases. B-Flow has many clinical advantages due to the higher spatial resolution compared to color Doppler imaging as seen in these images. What are some of the parameters that may be changed when optimizing B-Flow on the system? Since B-Flow is a B-mode technology, all of the same parameters can be changed as they would be in B-mode. We will discuss a few of these parameters. The first parameter to change would be the PRI, which stands for Pulse Repetition Interval. Increasing the PRI improves the sensitivity to slow flow states and small vessel identification. However, as the PRI is increased, the image has potential to flash due to interleaving or mixing of the signals. Decreasing the PRI is useful in high flow conditions and helps to minimize flash. However, as the PRI is decreased, sensitivity to small vessels and slow flow states is reduced. Similar to B-mode, frequency is changed based on whether more penetration is needed. When using B-Flow, frequency may be adjusted to see deeper structures. SRI, also known as speckle reduction imaging, helps reduce speckle noise in the image. Increasing SRI may enhance the flow profile. This can be done before or after the image is acquired. For example, in this thyroid nodule, watch the blood flow pop as we increase the SRI. Normally when using B-Flow, the tissue is suppressed. If a user desires to see more of the tissue, they can turn the background on, which enables them to see surrounding landmarks in the image. Background off suppresses tissue signal, allowing enhanced visualization of small vessels. Changing the tint map may help detect small vessels that may not be visualized in the current tint map. With the ability to change the tint map, a user may see a different level of contrast, which may improve the visualization of perfusion through an organ. Tint map A, for example, may accentuate the flow in a region such as the surface of the spleen. What are the differences between B-Flow and B-Flow Color? B-Flow Color is based on Doppler technology, which is similar to power Doppler, but with the advantage of higher spatial resolution. This higher spatial resolution gives B-Flow Color better hemodynamics and less color overwrite compared to power Doppler. Compared to B-Flow, which is not angle dependent and detects the weak echo signals of the red blood cells, B-Flow Color requires an ROI and is angle dependent, similar to Doppler technologies. Similar parameters will be used when compared to power Doppler imaging when optimizing a B-Flow Color image. The overall color gain within the image can be changed by using the color gain knob. This is the first parameter that improves optimization of the B-Flow color. The next parameter to adjust would be the scale, also known as the PRF. Decreasing the scale increases the sensitivity to slow flow. Increasing the PRF will enhance the hemodynamics in higher flow states. This is similar to how you would adjust power Doppler. Increasing the PRF will also decrease flash artifact. Selecting Enhance will help increase sensitivity. This parameter can be beneficial to use when imaging very small vessels, such as the renal parenchyma or the liver capsule. Changing the B-Flow color tint map may improve the ability to see enhanced color contrast when visualizing small vessels and perfusion. A map, such as B-Flow 5, may bring out the smaller vessels due to the brighter colors that are contained within that color map. This concludes our session on B-Flow and B-Flow color technology.